Rizwan, good to see you. It's been a while, we have not spoken.
Yes, sir.
My screen is good to go.
Yeah, Dave, it's visible.
So that's the whole point of today's workshop is learning about natural language first. We'll start with setting up the frame for today's workshop. So in this slide, we will understand the journey which we'll cover in natural language first. There's kind of a roadmap which we'll be following. First of all, we'll understand what is text data. It's more than just a word on a page. It's an unstructured information we encounter everywhere, from emails, CSVs, as Excel files, all the reviews over internet, social media posts, comments, all these things will come under textual data. So it's just not a word. It has three different forms in it. Further, we'll discuss that the three different structures we have under text data. Then we have NLP overview, which will cover the core fundamentals involved in NLP, how NLP is able to bridge the gap between computers and humans. As we know, we humans use unstructured and full of nuisance language, which is difficult for computers to understand, basically. So we will look into the techniques we can apply and use to convert this unstructured data to something which computers can understand. From there, get into the high level of NLP overview. We'll touch on what NLP is at its core, that it's a branch of AI that helps machine understand, interpret, and generate human languages. It's powering a lot of things in our market right now, like ChatGPT, translation apps, and even sentiment analysis done for marketing purposes. Just a minute. After that, we cover NLP overview. We'll get into the text pre-processing pipeline, in which we will understand the whole procedure, how a raw data comes in, and how we get something which can be used for analysis. How a raw text data can be converted to something useful for an analyst. Uh, Pre-processing can be explained like cooking. Like when you go for cooking, it's essential that you have a clean area. You have things with you. Whatever ingredients you are required to complete the cooking part, it must be there. So it's the whole part in pre-processing pipeline. We bring in all the libraries, tools, data set, and all the techniques, create a data that is useful to us. After that, we have tokenization, which is basically breaking text into smaller pieces like words or sentences, while normalization helps in smoothing out the variation in text. I'm just giving you the okay, sorry. I'm just giving you the overall idea right now. We will dive deeper into these topics one by one so that you get a better idea what they are actually. We are just setting the frame for now. After that, we complete normalization. We move into advanced NLP techniques like POS, part of speech, NER, name entity recognition. So these have different impact over the text, like POS, part of speech, could be used to identify the grammatical portions of the text. Which part of a text is a noun, adjective, verb, like the different grammatical aspects we have. And tokenization mainly is used to convert text, raw text, into tokens. Tokens are basically small chunks of data, small chunks of text, which can be provided to the models for further process. for further advanced NLP techniques. So let's start with what is textual data. So as you can see in the slide, we have break down it into three main categories: structured, semi-structured, and unstructured. This classification is important as it influences both process and how we analyze the data in NLP. Before we get into the actual NLP process, we have to identify what kind of textual data are we dealing with. Is it structured, semi-structured, or unstructured? Because all three of them have different approaches. So there's someone trying to join. There's someone trying to join.
No, please go ahead, Dev. I think there was some background, but it was not a question as such. Please go ahead.
Since I went back, I just lost that presentation. Is my screen visible now?
Yeah.
Yes, it's visible.
So we just covered what textual data is. And in textual data, we were understanding the three different types. We have structured, semi-structured, and unstructured. As you could see, the database text fields, which has particular columns and row, will come under structured. CSV columns used to mark reports and entries. Survey responses, which has predefined questions for which we fill the answers, and form submission, as we know, has empty blocks in which we can fill in the data, and it relates the answer with the required query. As we shift into semi-structured data, it has XML, JSON, HTML pages. It is not completely structured, but it has some kind of tags or HTML. It has some kind of hash keys present there in the data, which is used to map the text in the data. It is not as completely rigid as structured. Still has some tags and keys. Like XML uses hierarchical tags to structure content. We find this in configuration files or data exchange. JSON is similar and it is used for APIs and it's comparatively lightweight. HTML pages organize the web content, and email headers has the sender's detail, the receiver's detail, and the timestamps. So that's how they come into the semi-structured data. And unstructured, as we know, the most abundant data we have around us. The number will come around 80% of the total data is unstructured around us, which includes social media posts, reviews on different products, articles, legal and medical documents. Legal covers the claims, the legal claims. Medical documents cover the e-prescriptions and the clinical notes, which can help in early diagnosis. And then comes the books and research papers, which has different sections, but they all are unstructured. There is no certain format in which we have arranged it. So these are the three different textual data. And after this slide, we have a quick quiz to see who and all were engaged with me for this first topic. So the first question is, which of the following is an example of structured text data? So anyone want to go ahead and answer this?
Yeah, it's the CSV file.
CSV file.
Okay. What made you think so? Like CSV file is the right answer. Is there any explanation behind it?
Uh, there is the CSV file contains of comma separated values basically. So if we put them into an Excel sheet, it will be in the tabular form that contains a specific heading, and according to that, the values come. So,
So
like
basically,
we, it,
what you mean is you can organize it into rows and columns.
yeah,
Yeah, perfect. Next question is which format is typically unstructured?
Raw text from news articles.
And what makes you think so?
Yeah, because there is no particular format for making these news articles. They are just a perception or a news that is there. So that's why it is unstructured, not specifically into rows and columns.
Okay. Which of these represents semi-structured text data? Anyone who has not participated yet. What about again? Hamza has one.
it's the B option, XML invoice.
Yeah.
Any explanation behind that?
Just because XML it contains the tags like where the data is inserted. So yeah, it's semi formatted, not actually perfectly formatted within the
Exactly.
rows and columns, but yeah, it has starting and ending defined.
Perfect. Moving to the true and false, structured text data is always easier to process than unstructured text. Someone wants to take a call on
True.
this?
True.
Any explanation as particular why do you think it's true? Why is it easier to process structured text data over unstructured data?
Because processing anything on the structured data is easier as compared with unstructured data, because nothing is defined in that. So you need to firstly you need to structure it, then only you can apply any processing or anything which you want to do on that.
Okay. Social media posts with hashtags and mention are considered completely unstructured data. Anyone?
It's true for that because social media tags can be anything related to it.
Why do you think it's true? Like just because it's a social media post or anything
No,
else?
it's a random like hashtags are always just a hashtag and name convention after it. It can be randomly any name out there. It doesn't make it semi-structured like the semantic tags of HTML or JSON or JavaScript because they're random text after the hashtag. So probably they are completely unstructured.
So here is the catch. If it would just be another social media post, then we would have considered it as an unstructured data. But the thing to notice here is we have hashtags and mention. And as we use social media, we came across posts that has hashtags and mention relevant to that post. Like if some post is about artificial intelligence, then you will for sure find hashtags related to AI, ML, and such hashtags at the end. So if a post comes with a hashtag or a mention, then we just can't completely call it unstructured data. It will somewhere come in under semi-structured data because it has some tag. If you go on to Instagram and you search for a hashtag, you will find all the relevant posts through that tag, through that hashtag. So somewhere that data is being structured, like there is something which is identifying that post. That hashtag is being used to identify that post, to identify the context of that post. So there's a false for now. It will come under semi-structured data. But still 100 marks for the try efforts.
Dev,
Going
may
to
I?
the Yes, sir.
I think the point that was raised by Sahaj, I think Sahaj, the explanation that you gave, I think you need to refine it a bit more. Um, when we are dealing with structured data in particular, right? First of all, the programming language has evolved a lot, right? The moment you bring SQL into picture, right, you can easily query the data, right? You can easily qualify that, okay, this is a segment where probably the age is kept here, maybe the explanation about a description about a student is kept, right? I mean, it is very well structured, and that's why we call it as structured data. When we are dealing with unstructured data, the larger problem is that you may not know where you have to actually pick up the intel from. So they say a text which is kind of 100 words, and you have to figure out who has written it. What is this text is communicating, right? There can be straightforward things. Starting from character X to character Y, where something has been written, you have to write a parser on top of it. Right? Again, it is an additional task. On top of it, the recent advancement that we have seen, if it is a paragraph which is of 100 words, right, probably you would also be requested to understand the intent, right? So all these expectations and the loose structure makes unstructured data difficult to deal with. So this can be something that actually can be asked in different forums. So that's why I wanted to be absolutely sure that you are getting this information correct, Sahaj.
Yes, sir.
Any
Thank you,
doubt
sir.
on that?
Thank
Yeah.
you, sir.
All
Thank you.
right.
It's clear.
Back to you, Dave.
Yes. Um, so we're good with the quiz. Going to the next deck for the NLP overview. So now that we have explored the different types of text data, let's zoom out a bit and talk about the NLP itself, like what it is, why it is so transformative, what is so special about it. So this slide specifically captures the essence that NLP brings in. As we could see on the left of this diagram, that computers excel at structured data, and at the right, we could see human communication is equal to unstructured text or speech. This is a fact we all know that computers are good at structured data and humans communicate in unstructured way. So what should fulfill this gap between them? And that gap is fulfilled by NLP itself. NLP is used to fulfill this gap between computational power and the human communicated text. As if we go into the definition, it says natural language processing is a subfield of AI focused on enabling machines to understand, interpret, and generate human language in a meaningful and useful way. So these are the three major aspects NLP is providing us. You can understand, you can interpret, and you can even generate human-like language in response. So in brief, we can build a conversational agent using NLP. Before we move to the next slide, there are a few more things we can cover. What are the major goals of NLP? Like understanding, understanding the meaning of text, what text is it's being fed with. Hello.
Dave, you're audible.
Yes. So hello. So there is some reconnecting thing happening at night.
You are audible here.
Okay. So as we were as we were discussing the NLP gaps the bridge between human language and the computer. It has majorly four tasks to do: understand the language, process it to make it feasible for the computer to feed in, and generate something which seems like human-like response. And it is also used for translation purposes in machine translation. Right? We can have bilingual translation across languages. So these are the major goals which NLP carries. Why is it difficult to have NLP? Why is it taking so many years for us to like proceed ahead in NLP? Why are we already not having these voice assistants and conversational agents around us? Why is it so difficult for us to connect NLP with real world use cases? That's what we'll discuss in this slide. The very first problem, the very first challenge we have is ambiguity. As our human language is messy and full of ambiguities, it's quite difficult for machines to understand what we actually mean. The very classic example for this is I saw the man with telescope. So I just want you guys to participate in this one thing, that what are the different meanings you can interpret from this one sentence. So I'll expect you guys to participate in this. What is the very first meaning comes in your mind when you read this? Yeah. What is the very first meaning comes in your mind when you read this line? I saw the man with telescope.
It's simply a man carrying a telescope.
Okay, that is one of the interpretation. Anyone else?
He has interest in astronomy.
Like
Uh,
not like that.
yeah,
This,
it
but
also says that with the help of a telescope, I saw that man. So that's the other meaning, which is creating
exactly.
ambiguity.
Yeah. Anyone else with any other interpretation? So if you talk about it, there are multiple interpretations. We will cover a few of them. There is a man on a hill, and I watched him with the telescope. That is also a meaning of this line. Yeah, there is a man on hill, and he has a telescope, as we got from the audience. I am on a hill, and I saw a man using my telescope. I am on a hill, and I saw a man who has a telescope, as Anil sir said. And there is a man on a hill, and I saw him with something with my telescope. And it continues. It continues, and it has more and more meanings like this. But this issue arises for us humans. We humans are struggling to find one particular meaning for a sentence. So how can we expect a machine to understand that? So this is a very big difficulty we face in NLP. Next is context. Context of words in different places. Like a same word bank may also mean a financial institution, or on other hand, can also mean a riverbank. So it depends where it is being used, what is the surrounding sentence of that word, through which we understand, okay, this could be the possible meaning of this word out here. So machines don't usually have this amount of uh, efficiency to do such kind of process. We do it normally, casually. We have been trained that way. We know how to understand language. Machines are not. So we have to break it to their level. We have to feel into each layer of the language to make it understand what the text actually means. Again, we have variations of text. A word great, Great, can also be written as GR8, a slang, short form. Or we can also term it as awesome, even though they mean same, but quite difficult for the machine to understand they are same. Like they are looking different. The spelling of great is different. The GRE8 is different. It might take it as a different word. So how can you make it understand that, okay, this great and GR8 is same? Grammar. Then comes the grammar. As we have different parts of speech, A single line might carry a noun, an adjective, and verb. How can you tell the machine that this part is a noun? Or the same noun word might appear as any other form of speech at any other line. So words carry different meaning at different places. And then comes the most interesting part, sarcasm and humor. Like we all know, yeah, right. If someone says, yeah, right, that could be either a complete affirmation or like it could be a humor also. Like someone might be sarcastically saying, yeah, right, you are always correct. Like in that sense. So it could be a complete agreement or a complete disagreement. So a huge difference between both the meanings. We have to let machines understand that. So for these kind of difficulties, we have a structured format for which we through which we identify the meaning, the context of the language. To handle such task, we have at first lexical analysis used for identification and analysis of word and their structure. Like it focuses on identifying and analyzing individual words and their structure, like by breaking down. Unhappiness can be break down into unhappy, like the negation and the root, and the ness, the noun form. So that's how a vocabulary is built. Then comes the syntactic analysis, which understands the grammar, how words arrange to form sentences. This is about parsing structures. And we use tools like parse trees here to form sentences and create grammatical sense in them. After that comes the semantic analysis, which captures the actual meaning of the word and sentence, goes beyond the structure and interprets the intent behind it. Like if someone says apple, what does the first thing comes in your mind? Like, is it a fruit or a tech company? It depends where it's appearing. For a machine, how can you tell the machine that whether this apple is a organization or a fruit? The difference is difficult. So this part is done by semantic analysis, where it is responsible for capturing the meaning of word in the particular sentence itself. Going ahead, we have pragmatic analysis. It takes it further by using context and real world knowledge. We use real world knowledge to understand like there is an example in this. Like, can you pass the salt? This this question isn't about the ability that can you pass the salt. It's a request. You are requesting the other person that can you pass the salt to me? So these kind of situations, these kind of tasks is handled by pragmatic analysis, where we understand the speaker's intent, the norms, the situational awareness, and finally we have discourse integration. It is used to understand the conversation by looking at the preceding and succeeding sentences of the current token. Like we see if somewhere it's mentioned that it's written it, so there must be some preceding mentioning about this it must be mentioned somewhere. Does this it refer to? So such kind of relation between sentences and context is completed by discourse integration. So these are the different layers used to analyze NLP system and tackle our difficulties mentioned before. Since nowadays we have such modern models which could handle all of these problems at one, like one single model can is able to handle all these difficulties at once. So is there anything you guys like to ask or you find something difficult till now? Like as we have covered the core fundamental about NLP and the difficulties about NLP and what solutions do we have to fix these three aspects we have covered in NLP. Someone has any doubt, query, come on. I believe silence is affirmation to know. Everyone has understood everything. So should I come up with some quick quiz or questions? Check who was in the loop. Yeah,
Yes.
not now. Choose the right time for them. So let's dive into some of the common NLP applications around this. So now that we have unpacked the challenges of NLP, and we can highlight some of the common applications like text processing. But actually, text processing is understanding the speech and detecting the emotion out of it. Like whether a review is positive, negative, neutral. This is a part of text processing. Like you have multiple reviews of a product over these e-commerce website. Within a click, you can categorize the negative ones, the positive ones, and the neutral ones. How is it done at the back? NLP is actually working to process these text and categorize them based on the tone used by the user. Then we have text classification, very well known for spam and non-spam emails. Like whether our email is spam or non-spam is classified by some of the keywords present in the mail, like off, sale, uh, urgency. Like these are some of the keywords used in spam mails. So such keywords could be used to classify, categorize whether a mail is spam or not. Then we have named entity recognition, used to extract names, places, organization. Example, Apple in California. So here Apple is an organization and California is a geopolitical entity. That's how we categorize named entities from the whole chunk of text. Am I clear till now? As I could see, very minimal interaction from you guys.
Yeah, it's fine.
Yes, it's clear.
I think I have a point to add. So
Yes.
when we're talking about spam versus non-spam emails, we picked up a case when we were learning supervised learning in particular, right? And that's where we had a classification technique that we were discussing, right? Where the identification whether a particular email will be spam or not, right? I mean, that's a kind of learning model that you will create. Now, this is where the challenge that we have, right? And this is where the complexities rise. So the way we had that conversation, it was a very, very basic one. Picking up certain words and qualifying that a particular email is actually a spam, right? Because it was primarily for an academic reason, right? We actually had simplified it. However, when the spam algorithm will be applied, it will be much more complicated. So this is where NLP will come into the picture. The text classification, which they've just spoke about, right? That will actually form the basis, right? And then the details that have been brought up using NLP, that will be passed to an algorithm, which is kind of supervised in this case, right? So it's going to be a combination of multiple techniques that you need to apply. So the moment you get into industry kind of scenario, the problems will be much more complicated as they appear to be. It's just that there is a simplification that has been done. So my suggestion is when you are looking into NLP use cases, when you are looking into the different problems, and probably you're trying to qualify that, okay, this is an NLP technique is supposed to be applied. Think about the entire solution end to end, right? And that's where your knowledge, how things work, will improve. All right, I just wanted to add that. Back to you, Dave.
Yes. Exactly. Like when we go through the whole process of any use case, then only we understand the complications and uh, the struggle, the whatever where you can go off. Uh, that's the learning you get from the implementation part. So moving to the language understanding, this is where NLP really mimics human comprehension. Like machine translation handles converting text between languages seamlessly. Google Translate, you all know about Google Translate, how easily it could translate between different languages. It has no barrier. It could come. We can communicate in any global language using Google Translate. And then we have question answering systems like Siri, Alexa, ChatGPT provides direct response to queries, drawing from vast knowledge base it has already saved. And text summarization condenses lengthy documents into bit-sized overview, like which is easy to digest, perfect for news articles or research papers, so that you can have a grasp of key points without reading the whole novel or the whole research paper. You can get a quick summary about any data, any corpus you want. On the speech and generation side, we are blending audio with the text. Speech recognition turns spoken words into written form, mostly known as transcription, enables voice assistance and transcription services. It's like dictating notes during meeting for accuracy and efficiency. Every word you speak will get converted into text as a transcript. So behind every transcription process also. And nowadays we have some of these media player apps which can convert real-time subtitles. So behind that technology also we have something like this only, which is simply converting the voice, the speech directly into the text at real time. Then we have chatbots, as we all have used chatbots and conversation agents. Uh, Conversation agents are mostly being used at these uh, uh, customer services like food delivery apps and e-commerce website where we have something to ask to the uh, customer service, but the other person at the end is not a human. It's actually a agent sitting out there, reading out your query, understanding your context, and giving a human-like response to you. So it used to be predefined chatbots before NLP came in. Uh, we used to hard code replies for the queries. But the moment NLP stepped into this field, we are well equipped to reply like a human, to understand the query, what the user is putting in. So that's the extra edge we have got through NLP and its most latest models and yeah, exactly models we have right now in the market. So apart from that, it is able to handle queries 24 by 7, which is able to boost overall satisfaction of the customer. Like if you find a conversation, if you find a customer service available for you 24 by 7, because there is no human actually sitting out there to reply. It's a conversation agent at the other end for your queries to handle. So it improves the overall experience. Like as we have already heard before that will be the era of AI where AI will come into the lifestyle of you. So these are the small implementations of AI into our lifestyle. Then we have content generation with tools that could create, write, and even can create code suggestions. We have AI assistants uh, inbuilt to our IDs through which we can write codes by just providing the context of the code. So these all are somewhere the applications of NLP. Finally, if we connect this to business, then that becomes the real world use case. Like if we connect NLP use cases and NLP application with real world use cases, we come out with something business. We create business through that. For example, in retail or hospitality, customer feedback analysis uncovers insight from surveys or reviews to refine their services. Like it's easier for them to tackle and understand where they are going wrong through these customer feedback analysis. Social media content moderation to detect harmful posts, keeping platforms safe. Such kind of applications have become easier using NLP because we are looking for keywords in the post, harmful keywords or that uncensored content through text. So we are able to monitor all these social media activities using NLP. Mostly Twitter tweets are monitored using NLP, not the visual content. I'm talking about not the images, not the videos. I'm talking about the textual content we post online, like blogs and tweets. So these are being monitored through NLP. Then we have legal document reviews and contract analysis. So for a fact, European countries have already adopted this use case where you can apply with your case. The bot will read your case and will give a verdict based on the learning it has made through its last 100 years of cases. Like it has a corpus of 100 years of cases. Like a good lawyer will do. A good lawyer will understand your case and will give you a verdict what that could come from a judge. Similarly, our bot is doing that for a human at a very small cost of £5 for everyone. So these are the real world business use cases people are coming up with using NLP. Then we have medical record processing for faster diagnosis. Obviously, if we process the diagnosis, the clinical notes using NLP, then we can extract key symptoms and we can have an early diagnosis, which could save potentially life or money both. And then in finance, monitoring news and tracking sentiment helps to predict market shift based on public opinion. You have public opinion on one hand, and you can predict the market shift where the market might lead to using these public opinion, mostly used in democratic pollings, where these political parties already know which region of people are favoring to which political parties. So such kind of use cases are also under NLP. We would see some icons during this slide, which is like Grammarly for writing aid, helps in writing. Hugging Face has some of the open source models, which are state of the art models, and which could be used to perform very high end NLP applications. Then we have DeepL for the advanced translations. So is there any of the tools which you have already used or you have some experience with these tools? Is there something anyone has to come up with? Would like to share their experience with any of these tools? Anyone?
I had a doubt apart from this text, like NLP and large language models are not the same thing, but the large language models certainly use some part of the NLP, right?
Yeah.
We take the example of Google Translate, like it was just for translating, so it was doing one type of work, whereas as we compare it to ChatGPT, it can do multiple translations as well as understanding our code. So that's why it's under the large language model thing.
So what is the question in this? I am not able to extract the question out.
So as we have included, like there are other also like Grammarly, Quillbot, IBM Watson, Hugging Face. Like there are purely based on NLP or more on the LLM. Like Google Translate certainly uses NLP at its core probably, not the large language models. Is it so, or I have some misconception?
I'll explain it to you. It's like NLP is a technology in itself. NLP is a part of AI, a field of AI which deals with converting the language to which bridges the gap between human and that we have already discussed. But the point to understand here is LLM plays a different role. LLM is the most advanced models which we have right now, like BERT, GPT. These are the one of the most state-of-the-art models, which can do and perform beyond any expectation. But before we reach to those models, we have to understand what are the traditional NLP techniques. Because it's not necessary for every use case you start applying LLM. It would be a simple waste of resource. So first we have to understand what is the problem. What is the problem statement? What are we required to do? And according to that, we select the model. We have options to select LLM also. We have options to select simpler methods like TF-IDF or POS, part of speech, or NER, named entity recognition. These are the simpler techniques used in NLP. So the technique depends on the use case, what use case you are bringing. For example, if we are working on spam and non-spam email, for this, we can work with any traditional ML algorithm. Any traditional ML algorithm will be sufficiently able to discriminate between spam and non-spam. Here we don't need to use any LLM. But if you go into something more complex, which requires more aspects of like understanding, like if it's a document extraction, we are uploading some document to any website, and that website has to extract information from the document. In such use cases, we can apply LLM. In such use cases, the traditional NLP techniques will fail or might fail. So was I able to clear your doubt? Hello.
Yeah, and just to add to that, Hamza, see the way we should look at LLMs in particular. Uh, you can assume, right, even if they are black box in certain cases. Not all the LLMs are actually black box, but uh, some of them definitely are. It's kind of LLM, the NLP, the deep learning algorithms. Actually, they have kind of found the basis of creating LLMs. So while the data was getting scrapped, where you are accumulating the information from different resources, be it from web, or be it from the books and all, right? I mean, tremendous effort, Herculean effort has gone into gathering data before the LLM models or the foundational models came into being. Right? And then there were multiple algorithms they have applied. NLP is one such technique that they have applied. So in a way, you can say that LLMs is and the output that you see is a combination of NLP, is a combination of transformers. It's a combination of multiple algorithms which are there in deep learning, and on top of it, supervised learning and unsupervised learning. So to the best of our understanding, almost everything is coming into play here, Hamza. That's how the LLMs are working. And transformers in particular, and I think we have spoken about it a couple of times as well. Transformers particularly has changed the game completely. In 2017, there was a paper that was submitted on transformers. 2017 and 2018, that actually led to the formation of OpenAI. So by 2018, they had the first model which was not released in the market. By 2020, that was GPT-3. The first model was released. I think it was around 2020. And so that's how we have to look at it. These are the foundational blocks for LLMs. I mean, they are powering LLMs, Hamza. I believe it was Hamza, right, who asked that question.
Yeah, sir. Yeah,
So
I
did
got
you
it.
get it? Or we are completely? I mean, you were expecting a different response, and
Somewhat.
we, okay, let's pause here in that case. So can you ask your question once more? Maybe our interpretation is slightly different.
So basically, like I have worked using NLP in my projects. So that's why I was asking that it was basically a summarizer that I was using through made through natural language processing. So I used the AI model of the part first, so it wasn't much efficient. So one was it I was using the translate part also. So that's why I was confirming that it's pure NLP or just not the large language model part, because I use the large language model to do both the things. Uh, uh, Translate as well as summarize. So that's what I was asking.
Yeah, so you can safely assume that you are just using an interface, but
Yeah.
underneath it is NLP,
Okay.
right? And many more complicated algorithms that have been applied together. But essentially, the base is NLP.
Okay. Okay. Yeah.
Back to you, Dave.
So we covered the implementation of NLP application into real world use cases, how we can create business out of it. So anyone has any doubt in this NLP application can come with it. Or else we can go ahead to the next slide. Okay. So as we have discussed earlier, the real world use cases to applying the applications of NLP are some of them are chatbot answers. Uh, let's dive deeper into this. Uh, the customer support, first of all, it covers chatbot answers, FAQs and complaints, and virtual assistants provided 24 by 7, like Amazon customer service bot. So these are some of these services provided using NLP. Then we have finance. Yeah. Yeah. Is my screen visible to you all?
Yes, it's visible.
So uh, hello.
Yes, you are audible.
So after customer support, we have finance. In finance, we use NLP to analyze the news to understand the market trends, whatever there is a change in the market to understand the upcoming shift to detect different anomalies in the transactions. Uh, Such anomalies can be fraud. Uh, One of the very useful application is in stock market, where we can get a real-time insight about the share values, the rise or fall, using an. Then we have social media, where we can track brand mentions and public opinions, identify trends as they emerge. So the NLP not only works at customer support or finance or social media. There's much more real world applications, which which like apart from social media, we have healthcare, where we can extract meaningful information from the prescription, the clinical notes. We can do drug discoveries, and we can support diagnosis using the NLP applications. Like the example in healthcare is early disease detection from clinical notes. Then in education, the educators can use to create the answer sheets of students automatically using NLP. This is already being done by some of the LMS platforms available. They're automatically grading the answer sheets using NLP. Then we have support language learning apps like Duolingo. Duolingo is well known for that work. It has an AI feedback system which gives you feedback over what you write in different languages, so that you can learn different languages out there. Then we have in e-commerce. It can read product reviews for sentiment, that whether a review for a product is positive, negative, or neutral. It could be extracted through the tone of the review. And then there is personalized recommendation, like people who bought this might also bought that. Like it's a popular and observation done that people who go to supermarket to buy diaper usually come out buying few more things, and which is usually mostly common in most of the people. Like if someone is going to buy bread, for sure he might also buy a butter or an egg also with that. So such kind of relation between um, the purchase done by people can be also monitored through these NLP. Um, Supermarkets use these tactics to bring such things together so that their sale increases. Like they will try to keep bread, butter, and egg in the same row, or like some more certain things which are bought usually together. So these were the real world applications of NLP. If someone has any doubt in six of them, can come up with defining point. Confusing. Anyone? Or there is anyone looking for more explanation behind these applications? I'll take silence as no. No one has input. Should we move on to the next slide? In that case, so this is a huge break in our presentation today, like understanding the pre-processing pipeline. This is very crucial for us to understand how actually the raw text is converted into something useful, something meaningful. So from now onwards, we have to focus really hard what we are actually doing, this pre-processing pipeline. So let's get into this implementation of NLP. So this slide will show you the step-by-step workflow, breaking down to 6 key stages to make the process feel more approachable and logical. It's like a recipe. Like you are building something, you are putting raw things into something, and the outcome is something very powerful, very constructive. So that's the summary of this whole workflow. We'll understand one by one what is happening in each step. So very first is import and load. This step is known to set up a toolkit, what and all libraries we need, what and all tools we need. So for that, we bring in libraries like NLTK, which is used mostly for lemmatization or such uh, basic basic tasks like tokenization or POS tagging, or to uh, like we have already discussed, tokenization is converting text into small chunks, and POS is part of speech tagging, which is used uh, to tag the speech, what part of it is noun, verb, conjunctive, and adjective, and all. So these kind of task is done by NLTK. Then we have Spacey, which is used for optimizing. It's optimizing for the industry use cases. Then we have Hugging Face Transformer, as Hamza asked before, that can be used LLM into NLP. That's the case. We can implement NLP using Hugging Face Transformers. It has pre-trained deep learning models, which in themselves are a state-of-art models. Then we load the data. So the data is like the fuel. We need data which should tell the model on what grounds we have to uh, predict. So we upload the data. So import and loading of data comes in the step one. Then you need the right tools. like you need the right library to perform certain action. So you should be aware of the libraries required for each task you will be doing. You just can't get dependent on any one particular library for all the tasks. So when we are done with loading and when we are done with importing all the required tools and libraries, we move on to the next step to clean the text. The raw data is full of noises, we know. Raw data can't be fed directly into the model. That would waste a lot of resources. So we have to clean the data. We have to remove noises so that irrelevant symbol and junk data is not fed into our model. And in this thing also there is one catch that you might keep the emojis or you might keep the caps on for our text for sentiment analysis. Because in sentiment analysis, the emojis and the uppercase matters a lot. An uppercase might show an aggression or rage by the customer, or an emoji might express the emotion the customer is feeling while writing the review. So we have to understand the use case. If it's a text extraction task, then these emojis and uppercase is irrelevant. We can simply remove it. But if it's a sentiment analysis, then we do need to consider them because it also counts. So here is a very simple funda that if garbage goes in, the garbage will come out. So whatever you will put it in, that is gonna come out. So what kind of data you're putting into your model, you have to be very careful and thoughtful about that. We have to remove junk data like HTML tags or punctuations so that it can become context dependent. Cleaning of text also includes normalization, which is used to reduce the words, like running will become run, eating will become eat. Such kind of transformation in the text is under normalization. Normalization has actually more things to do, like it also removes a punctuation, it also removes HTML tags, it is also used to correct the spelling. Hmm. Uh, can also expand contractions like don't can be expanded to do not. So these are the small things which you have to consider while you clean the data so that the final result you have after cleaning is something useful. So these are the basic tasks you will cover. In summary, cleaning text involves tokenization and normalization. These are the two major tasks you will perform in cleaning the text. Then we add meaning to the text. How do we add meaning to the text? We have already discussed it through POS or NER. POS is part of speech, which gives a relevance to the model that how many how many type of speech is used. Speech is used in like what kinds of grammar is used in the speech, like where a noun is used or where an adjective is used, when verb is used. So this kind of awareness is given to the model using POS tagging. Then we have NER tagging, as we discussed earlier, named entity recognition used for extracting the entities which is already being recognized, like the name of the healthcare or law, like like the name of organization or name of geopolitical places. Such proper nouns so such proper nouns could be identified using NER tag. Like we also have example. If I say Apple announced profit, so here the apple is not a fruit; it's a company. So how come the machine will understand that using NER tag? So these are the two steps we use to add meaning to the text. So we are halfway of our workflow. If anyone has any doubt till now in these three steps, we can clear it out right now. Anyone finds anything difficult to understand?
Can you please explain step 3 again a bit?
Okay, sure. So adding meaning. So now that it's our data is already clean, we have to enrich these tokens with deeper linguistic info. And how can we give this linguistic info? By using two of the techniques, POS tagging and NER tagging. POS tagging here stands for part of speech. It identifies that if the token in the sentence is a verb or a noun or an adjective, that identification of tokens in a sentence, that identification of words in a sentence is conducted by POS tagging. It improves the model to understand the grammar behind the sentence. And then we have NER tagging, which is used to identify entities like company names or patient details from the notes, or like healthcare report. Healthcare report has multiple named entities, like the name of the drug, or the name of the patient, or the name of the hospital the patient has been treated. So such kind of information will come under named entity recognition tagging, NER tagging. So these are the two methods we use to add meaning to our clean text. For example, Apple announced profit. Here, Apple is a organization. Announced is a verb. Profit is a noun. So these are the different part of speech. We have divided the text. Did I make myself clear to you?
Yeah, thank you.
And after this comes the real magic of NLP. The actual thing happens after this. When we represent these textual data into numerical form. As we all know, machines are not able to understand word or text or any language. They only understand the language of numbers. So we have to bring it down to the level of numbers. We have to bring it down to numericals so that we can feed such numerical data into our machines so that it can extract patterns and understand the context behind the textual data. For that, we have multiple techniques. We'll start from the simplest one, bag of words, which is used to count the words. It simply ignores the meaning. It will just count the number of words. So if I say I love NLP and I love AI, so it will count I as twice, love as twice, and NLP and AI as once. If that makes clear. Did you guys understood what I'm trying to say? Like if I say I love NLP and I love AI, so here I is twice, love is twice, but NLP and AI is once. This count of words is done by bag of words. After that, we have TF-IDF, which weighs the importance. It downplays the common words. Like it means that if a word appears multiple times in a textual corpus, then the weight of that word will be less compared to one which is rare. Example for this,